something really cool here I want to share with my viewers. And it's like when you know something else other than what you're told, and it's so different that when you look at establishment stuff on it, like on the main pages on Wikipedia and various other science articles, you can't help but to notice how many things are different and where they're like messing up. So I'm going to go ahead and read here the Exoplanet article and go ahead and point out the way I view it in light of this discovery of what really happens to stars. Yeah, today is August 9th, 2015. An exoplanet or extrasolar planet is a planet that orbits a star other than the Sun. Nearly 2,000 exoplanets have been discovered, 1942 planets in 1228 planetary systems, including 486 multiple planetary systems as of August 3rd, 2015. There are also rogue planets, which do not orbit any star and which tend to be considered separately, especially if they are gas giants, in which case they are often counted like WISE 0855 as sub-brown dwarfs. And I know the people that have read the theory can automatically tell where they mess up with this, the alternative. It says here, an exoplanet or extrasolar planet is a planet that orbits a star other than the Sun. A different definition would be an exoplanet is an evolving star. That's all it is. It's an evolving star that doesn't orbit the Sun. That's what a planet is. Nearly 2,000 exoplanets have been discovered since August 3rd, 2015. Well, since we know that the star is the young exoplanet, basically we've already discovered over 200 billion of them. Kind of beats your 1,942 by a couple magnitudes. And yeah, I also have the concept of rogue planets here. Well, that's how solar systems are made. You have a rogue evolving star or new star moving through the galaxy, and it adopts objects as it moves along in the galaxy. Those should be pretty common. Next paragraph. The Kepler Space Telescope has also detected a few thousand candidate planets, of which about 11% may be false positives. There is at least one planet on average per star. About 1 in 5 Sun-like stars have an Earth-sized planet in the habitable zone, with the nearest expected to be within 12 light years distant from Earth. Assuming 200 billion stars in the Milky Way, there would be 11 billion potentially habitable Earth-sized planets in the Milky Way, rising to 40 billion if red dwarfs are included. The rogue planets in the Milky Way possibly number in the trillions. Here's the way I look at it. It says here, the Kepler Space Telescope has also detected a few thousand candidate planets. Well, we've already corrected that. Every single star is a young planet. So if you see a star, it's a planet. It's a new, young, hot planet. Of which 11% may be false positives. Chances are their false positives include objects that are brown dwarfs or something like that. Those are ancient stars as well, so they're not false positives. You can include those now. They're NASA. There is at least one planet on average per star. Well, yeah. It's because the star is the planet. So statistically, it's going to work out the same way. And if people know statistics, that's basically what they're saying. That's what it means. Yeah. And to really understand why that statistic came to be, that's the reason why that is the way it is. And the other parts of that can be ignored. Next paragraph. The nearest known exoplanet, if confirmed, would be Alpha Centauri b, but there is some doubt about its existence. As of March 2014, the least massive planet known is PSR B1257 plus 12A, which is about twice the mass of the Moon. The most massive planet listed on the NASA Exoplanet Archive is Dennis, about 29 times the mass of Jupiter. Although according to most definitions of a planet, it is too massive to be a planet and may be a brown dwarf instead. There are planets that are so near to their star that they take only a few hours to orbit, and there are others so far away that they take thousands of years to orbit. Some are so far out that it is difficult to tell if they are gravitationally bound to the star. Almost all the planets detected so far are within the Milky Way, but there have also been a few possible detections of extragalactic planets. This is going to be more interesting. The most massive planet is 29 times the mass of Jupiter. Well, we know what a planet is when it's young. It's a star. So the most massive planet is as massive as the most massive star, or they're the same thing. Oops. And then it has here, although according to most definitions of planet, it is too massive to be a planet and may be a brown dwarf instead. So they try to make that demarcation zone between planet and brown dwarf again based off mass, not realizing that the brown dwarf is the younger planet. It's evolving and forming its interior, becoming the planet, and then its outer atmosphere will rip away. It's along the lines of a very long continuum of evolution, meaning the brown dwarf is an intermediate age star, not a failed star, and it's going to become the planet, meaning it's not going to retain its mass forever. It's losing it to interstellar space. Why this understanding has completely skipped over NASA's brilliant minds, I have no idea. And then the other parts we can ignore, except for this. It says here, almost all of the planets detected so far are within the Milky Way galaxy, but there have also been a few possible detections of extragalactic planets. Well, yeah, since the star is the new planet, if you see stars in other galaxies, those are extragalactic planets. They're young extragalactic planets. So there's that too. Now you can see where I'm going with this, why it's so different. All of this needs to be readjusted, all of it. It's unreal. And let's see if I can pull up the Jupiter page. Alright, now Jupiter, and here's one reason why I stress this a lot. You have the page on Jupiter. Now in the contents on this encyclopedic article are the formation and migration, structure, its composition, mass and size, internal structure, its atmosphere, planetary rings, magnetosphere, orbit and rotation, observation, research and exploration, moons, interaction with the solar system, possibility of life, mythology, notes, references, further reading, that kind of stuff. Did you notice what's missing? They had formation and migration, but they don't have its evolutionary path. They have the Jupiter, as being a big inert ball of gas. It's not doing anything special or incredible in its interior. Sure, they say, well, we don't know what's going on, but according to the theory I'm developing, we know what's happening in its interior. It's forming the planet, the Earth-like structure. So all the differentiation that's happening on the Earth is happening currently inside of Jupiter right now, when it was a much younger star, and it hasn't fully solidified. But we know that, and that's why it's much more powerful than Establishment's version of events, because they don't even have the eventual evolution of Jupiter on here. They don't know what's going to happen to it. They completely ignore that. As well, they completely ignore the eventual evolution of Saturn, of Uranus, of Neptune, and of all their exoplanets that they've been finding in interstellar space. It's kind of incredible when you think about it. They have evolutionary models just for stars, and they have planets as the byproduct of their formation, so they don't ever look at planets as being anything special. They're just these big inert balls of gas and dust and rock that don't do anything. Little do they know they are intermediate age stars, which are forming the very land that we stand on. The very ground you walk upon is being formed inside of evolving stars like Jupiter. But of course, I think I'm more or less coming to terms with a lot of this. The fact that this understanding is not going to make the mainstream for the next 50 years. It's going to take about 50 years before this understanding hits mainstream. Hopefully if I survive that long, I'll be probably, well, I'm 30 right now, so I'll be 80 years old. I'll be an old man with one of those walkers with tennis balls on the ends of it. Hopefully I make it to that long and nothing happens to me getting struck by lightning or something crazy like that. But anyways, I just wanted to point that out to you guys, to really take this theory to heart and then apply it to the articles that you read. Don't just focus on the stuff they have about, oh, the Big Bang and all this stuff, like really big things that are just so massive that you can't really wrap your mind around it. Try to focus on the smaller things, the things that actually move and change and that we can look at and interact with and that we can, you know, be real with, not theoretical. That's, I think, the power of this theory as well, is that it explains rocks and minerals. Like when you pick up a rock or a mineral off the ground, you know you're holding a part of an ancient star that's highly, highly evolved. But about 50 years. I give it 50 years. Alright, everybody take it easy.